Hi, my name's John with Mark 7 Reloading, and today I'll be taking you through everything that's new with Titan. When we started developing Titan, we realized that capability and throughput needed to be addressed in order to reach our goals of handling 338 Lapua Magnum, as well as increasing the output of these machines to what we wanted to achieve. 338 Lapua Magnum brings with it certain challenges that we hadn't had to address before. So we needed to attack Titan and its accessories with that in mind. We needed to be able to handle the extreme high end of rifle calibers, as well as increase our throughput for everything else. So starting from the top, on our case and bullet feeders, we updated them to 16-inch models to bring higher torque, higher speed, and higher capacity, conquering up to 338 Lapua Magnum all the way down to 380 ACP. Each case and bullet feeder has independent speed control, as well as a slip clutch to keep running even if you encounter a jam. Going down the feed here, we have our new IR case feed sensor. No longer do we have a mechanical switch or anything impeding the flow of cases or bullets. It's an IR eye that looks for the presence of that component to turn the feeder on and off. And lastly, we've updated our case feed platform area with stronger materials and better finishes for more longevity and durability through the life of the unit. Converting your 16-inch case feeder involves changing out your case feed plate, your output, and your lift platen on the back of the unit. By changing those three pieces out, we are able to go from small pistol calibers like 380 ACP all the way up to 338 Lapua Magnum. On the bullet feeder, similar operation of the plate and output can get us in the same ballpark for compatibility with a wide range of projectiles. The priming system on Titan is now stepper motor controlled. Regardless of the stroke of the machine, with this independent control, we can have our primer delivery be optimized to maximize output and minimize stoppages. No longer are we linked to the stroke of the machine itself for that function. Allows us to tune it for optimal performance. With Titan, we needed to update our powder measure as well to be compatible with the larger stick powders present in calibers like 338 Lapua Magnum. So to do that, we now have our high torque digital powder measure. This uses a larger stepper motor as well as a geared interface as opposed to a belt to cut through stick powders and provide a consistent powder fill regardless of the type of powder you use. In addition, we have fault detection and recovery built in. So if it does happen to get stuck on some kernels of powder or a bridge occurs, it has the ability to detect that and recover so you don't miss a beat during your loading. For XL rifle calibers like 338 Lapua Magnum, where you're dropping 90 to 95 grains of powder, you end up running out of capacity with most volumetric designs. So with our digital powder measure, you can operate two in sequence, each one dropping half the charge, or alternatively, you can run a double drop feature, where at the bottom of stroke, the powder measure will actuate twice, dropping two charges to adequately fill your XL rifle caliber. In addition to the flexibility of powder measures on Titan, you can also run two powder checks in sequence for added safety checks. At the end of the day, with more stations and more functionality, you can set up your tool head however you like to accommodate these larger calibers in a safe, high output situation. In small rifle and pistol applications, our high-speed digital powder measure offers the same functionality as the high torque with its stoppage detection and recovery, while maximizing throughput with ball and flake powders. To simplify setting up your digital powder measure, we've added the feature in the HMI to allow us to actuate the measure without having to run the press. We can take a primed case, stick it in the powder measure like so, and activate the drop to then get our measurement. This shortens setup time, helps remove some of the tedious nature of setting a volumetric measure, and overall leads to faster and more satisfying setup. For the bullet dropper on Titan, we went away from a mechanical system and developed a pneumatic bullet dropper. This preseats the projectile to your given depth to attack several issues you have with high speed output. We can get rid of expansion needed because the bullet is being preseated deep into the neck. We can get rid of bullet topple because that bullet is firmly in that case and retained. And we can also minimize our tool head stroke by seating the bullet deeper and not needing as much clearance during index. All of these things lead to more efficient and higher output. To go over how the bullet dropper works, we have an IR sensor here at the top to turn the bullet feeder on or off and keep our supply of projectiles constant. We have a drop tube with our stacked projectiles. We have our ram and our seat rod and our solenoid controls. When actuated, the ram, right here, shoots forward with a projectile and it prepares to be seated by the seat rod, which shoots down and seats the projectile in the case. The items retract and are reset for the next operation. The human-machine interface, or HMI, on Titan is your operator's control surface for everything on the machine. Once you're in the software, we can use the control, configure, sensors, and setup tabs to individually tune and control every aspect of the machine's operation. On the control tab, we have our rounds per hour speed control. We have the ability to engage or disengage the major features like the priming system and powder measure and bullet dropper. The ability to set our digital clutch on the fly. Select our run mode of either single or continuous, and jog the tool head up or down. In our configure tab, we can control the tool head slowdown, when and where. We can control our dwells at the top or bottom of stroke to account for powder dropping in the case. Control the height of stroke between XL, rifle, or pistol. Control our shell plate individually or leave it in auto. Set our bullet dropper settings and our priming system adjustments. Under sensors, we can turn our sensors on or off on the fly, depending on our operations. And in the setup tab, we can set the homing settings for our shell plate and priming systems to account for any drift or misset of the index of those units. In addition to having all these features built into the HMI, we regularly work with our customers on a case-by-case basis to meet their individual needs. Through the HMI, we have a wide range of tuning and setup features that we can implement depending on the use case. Thank you for joining me, and I hope you get the most out of your Mark 7 reloading equipment.